We have studied first three reaction intermediates in detail. One carbocation, second carbanion, and third one is the free radical. आणि त्यानंतर आपण कार्बिन या इंटरमिडिएटचं डिस्कशन लास्ट लेक्चर पासून जस्ट त्याची सुरुवात केलेली आहे. We have studied what is meant by carbene in the introduction, then also about the structure, generation, in short stability, and lastly reactivity of carbene. We have studied some of the examples of chemical reactions which involves a role of that carbene as an intermediate. Now let us see next one. Again, this is a very common intermediate formed during some organic reaction. There are so many organic reactions, very well-known reactions, which involve formation of that nitrene as an intermediate. Now let us see first what is meant by nitrene. Okay, consider a simple example. Okay, this is CS3, then CS2, single bond nitrogen. Single bond nitrogen. We know that generally nitrogen having one lone pair of electron, NH2 primary amine, secondary amine, tertiary amine, nitrogen having one lone pair of electron. But in this particular case, nitrogen having two lone pair of electron. Okay, as well as what's about the general valency of nitrogen? General valency of nitrogen, yes, it having three covalent bond, ammonia, NH3, primary amine, RNH2, then tertiary amine. Okay, generally that nitrogen containing compounds having three valency. The valency of nitrogen is a 3. But in this particular case, what's about the valency of nitrogen? Yes, that nitrogen having only single bond, only one bond, and therefore it is monovalent nitrogen species. This is monovalent nitrogen species. Okay, then what's about the charge on nitrogen? Yes, it do not having any charge. Valency of nitrogen is a 1. How many electrons are there in the valence shell? There is only one single bond. That covalent bond having 2 electrons means there are 2 bonded electrons. There are 2 bonded electrons, while that nitrogen having 4 non-bonded electrons. Means totally there are 2 plus 4 means there are 6 electrons in its valence shell. It having 6 electrons in its valence shell. म्हणजे आपल्याकडे काय माहिती आहे about that nitrene? In nitrene, nitrogen is a monovalent species and it having 6 electrons in its valence shell. Now how will you define it? The monovalent nitrogen species which having 6 electrons in its valence shell is called nitrene, and this is an example of nitrene. Okay, is it electron deficient or electron rich species? It having 2 lone pairs of electron, and we know that generally ammonia, primary amine, secondary amine, tertiary amine, these are electron rich species because there is a lone pair of electron. Now in the nitrene there are 2 lone pairs of electron. Even though it having 2 lone pairs of electron, this species is electron deficient. This species is electron deficient because there are only 6 electrons in its valence shell. It having 2 electrons less to complete its octet, and hence it is electron deficient species. And therefore, in chemical reaction, it acts as a electrophile. Yes, it is an example of electrophile. Okay, this is just about the introduction. What is meant by nitrene? Okay, now let us see next point. Structure of nitrene. Nitrene can be existing again in 2 forms. One is a singlet nitrene and second is the triplet nitrene. We will see one by one both these structures, both these forms of nitrene. First about the singlet nitrene. Actually, in singlet nitrene, the hybridization of central nitrogen is sp2. In nitrene, okay, central atom is a nitrogen and its hybridization is a sp2. Means 1 s orbital and 2 p orbitals. They undergo mixing and recasting, and there is a formation of 3 new orbitals, and these 3 orbitals are called sp2 hybrid orbitals, and that process is sp2 hybridization. In nitrene, singlet nitrene, the hybridization of central nitrogen is sp2, means there are total 3 sp2 hybrid orbital. Suppose one hybrid orbital form one covalent bond. Now this nitrogen also having two more sp2 hybrid orbitals. Okay, these are the sp2 hybrid orbitals of that nitrene, but they do not involved in the bond formation. Okay, these are the sp2 hybrid orbitals of nitrogen. Now this nitrogen also having non-bonded 2p orbital. Okay, this is the non-bonded 2p orbital of nitrogen which lies perpendicular to the main plane. Now, what are the positions of electron pair? Nitrogen having two lone pair of electron. Out of that, one electron pair is present in one hybrid orbital, while another electron pair is present on second hybrid orbital. Means that two lone pairs of electron are present on two sp2 hybrid orbitals of nitrogen. They are having opposite spin, and thus non-bonded electrons are paired and they are having opposite spin. Okay, this is just about the singlet carbene. Now let us see about the second one, triplet nitrene. In a triplet nitrene, there is central atom nitrogen, and hybridization of that central nitrogen is the sp. Out of two hybrid orbital, one hybrid orbital form one covalent bond. Now this nitrogen also having one more hybrid orbital. This nitrogen having two unhybridized 2p orbital. Okay, this one is the first one and this is the second one. Okay, this is the second one, and thus nitrogen having two unhybridized 2p orbital. Now what is the position of electron? Actually nitrogen having two lone pairs of electron. One lone pair of electron is present in that sp2 hybrid orbital. It is present in that sp2 hybrid orbital, and these electrons are paired with opposite spin. Now it having one more electron pair, and these two electrons they are present in that 2p orbital. मग एक इलेक्ट्रॉन एका 2p ऑर्बिटल मध्ये असेल आणि दुसरा इलेक्ट्रॉन हा दुसऱ्या 2p ऑर्बिटल मध्ये असेल. They are not paired. Yes, they are having parallel spin. Okay, this is just about the triplet nitrene. मग ट्रिपलेट आणि सिंगलेट नायट्रीन मध्ये वी हॅव स्टडीड व्हॉट इज द हायब्रिडायझेशन ऑफ नायट्रोजन. सिंगलेट मध्ये होतं sp2, ट्रिपलेट मध्ये आहे sp. त्यानंतर त्यामध्ये इलेक्ट्रॉनच्या पोझिशन्स कशा आहेत. ऍक्च्युअली इन सिंगलेट नायट्रीन बोथ द इलेक्ट्रॉन पेअर्स आर प्रेझेंट इन sp2 हायब्रिड ऑर्बिटल. पण ट्रिपलेट नायट्रीन मध्ये मात्र वन इलेक्ट्रॉन पेअर, वन लोन पेअर ऑफ इलेक्ट्रॉन इज प्रेझेंट इन sp2 हायब्रिड ऑर्बिटल अँड इट हॅव्हिंग अपोजिट स्पिन. इट इज पेअर्ड हॅव्हिंग अपोजिट स्पिन. आणि दुसरी इलेक्ट्रॉन पेअर मात्र एक एक इलेक्ट्रॉन 2p ऑर्बिटल मध्ये असेल आणि त्यांची पेअरिंग होत नाहीये बिकॉज दे आर अनपेअर्ड हॅव्हिंग पॅरलल स्पिन. ओके, दिस इज जस्ट अबाउट द स्ट्रक्चर ऑफ दॅट नायट्रीन. Now let us see next point. Generation of nitrene means how that intermediate is generated, how that intermediates are formed during organic reactions. Okay, now let us see first method from azide. Okay, this is actually azide R and 3. We can write R single bond nitrogen, and again triple bond nitrogen. There are one nitrogen having negative charge and second having positive charge. Okay, this is actually a simple general presentation of azide. When it is heated or exposed to the light, it loses nitrogen gas. Means it undergo decomposition. Okay, there is a breaking of this particular bond and there is a loss of nitrogen gas. And now this nitrogen becomes neutral. Actually, there is a negative charge. Means there is an electron pair. Suppose this is the electron pair on the nitrogen, and it's also having one more electron pair. म्हणजे ऑलरेडी त्या नायट्रोजन कडे असणारी there is one more electron pair. Suppose this is another electron pair, and that species is called nitrene. And thus, azide on decomposition, when it exposed to the light or when it is heated, undergo decomposition, loses nitrogen gas, and we get the nitrene. Actually, this is okay. Now let us see another example. So it is acyl azide. Actually, when it is exposed to the light or when it is heated, undergo decomposition, loses nitrogen gas into gas, and there is a formation of R-C double bond O, and this is again acyl nitrene. This is the first method. That means from azide there is an easy formation of nitrene. Azide on heating or when it is exposed to the light, we get corresponding nitrene. Okay, now let us see next method from isocyanate. Now what is meant by isocyanate? R N double bond C double bond O. Actually, if the compound having this group, that compounds are called isocyanate compounds. Okay, N double bond C double bond O. Okay, this is the isocyanate group actually. When this compound is exposed to the light, it also undergo decomposition. Okay, now here there is a breaking of a bond. This bond actually undergo breaking. Electron pair goes here. One electron pair goes towards nitrogen. Okay, actually both the bonds undergo breaking, sigma as well as pi bond, and there is a formation of carbon monoxide. यामधून carbon monoxide बाहेर पडतो. There is a loss of CO, carbon monoxide, and the main species intermediate is nothing but the R single bond nitrogen, and now this nitrogen having two electron pair. म्हणजे इथला एक बॉन्ड ब्रेक झालेली इलेक्ट्रॉन पेअर, while that nitrogen already having one electron pair, and thus it having now two electron pairs, and this is nothing but the nitrene. Okay, thus isocyanate on decomposition, when it is exposed to the light, we get nitrene. Now let us see next method from sulfonylamine. Sulfonylamine. Okay, this is the sulfonylamine. Suppose pH indicates so there is a phenyl group, N double bond S double bond O. This is the sulfonylamine actually. Now this compound also when exposed to the light undergo decomposition. इथे सुद्धा या बॉन्डचं ब्रेकिंग होतं. There is a breaking of this both the bonds sigma as well as pi bond. One electron pair goes towards nitrogen, one electron pair goes towards sulfur, and there is a formation of pH single bond nitrogen, and this is again nothing but the nitrene and loss of SO. Okay, sulfur monoxide. And thus, by using isocyanate, by using sulfonylamine, there is a formation of corresponding nitrene. Okay, now let us see one more method from nitro and a nitroso compound. Nitro means NO2, the compounds which having NO2 group, and nitroso means the compound which having NO group. Okay, suppose this is a simple example of nitro compound. This is nothing but the nitrobenzene. pH indicates there is a benzene ring. Now this nitrobenzene on a reaction with triethylphosphine, when it is heated with triethylphosphine, it undergo reduction reaction and we get the monovalent nitrogen species, and this is nothing but the nitrene. Okay, thus by using nitro compounds, nitrobenzene, there is a formation of nitrene intermediate. Now let's see another example. This is the nitroso compound. Here pH means benzene ring, and NO group, that functional group is attached to that benzene ring. This is nitrosobenzene. When that nitrosobenzene is created with the triethylphosphine at high temperature, here also same type of reaction occurs, and we get the corresponding nitrene intermediate. Okay, this is just about the generation of nitrene. We have studied some of the methods in which, or some of the organic process in which there is a generation, there is a formation of that nitrene intermediate. Okay, first one is the from azide. यामध्ये पहिले मेथड आपण पाहिलं होतं by using azide, then second from isocyanate, third from sulfonylamine, and fourth from nitro and nitroso compound. Okay, this is just a generation of nitrene intermediate during organic reaction.